Hello, hello. Hi guys. My name is Piyush, and I work for a company called Zomato, and I'm an Android engineer there. The topic today is Jetpack Benchmark and where to find them. Uh, this is the company where I work at. We are one of the India's first everything related to food app. We do online ordering, we do dining, and it's a one-stop destination for people to order food online and discover the best dine-out places and everything. Most of the audience in India, back in India, they have mid-tier and lower-end devices. So something around $100 to $200 is the device, which is the average one, and which means lower processor and lower RAM, thus the issues. So these are some of the reviews which we got before we actually deep dived into it. The last one is my favorite. It must be a developer. So the reviews are like the latest update completely messed up the navigation. I'm unable to scroll or select restaurant. So basically we have a homepage which displays a list of restaurants. So, and people are facing issues regarding the scroll of it. And this is the pre-benchmark era. Before we implemented the benchmark library, these were the reviews. And this is what the profiler looked like. As you can see, we had a lot of inflation issues, and that took a lot of time to figure out. And so we deep dived and checked all the funnels, and we are trying to find a solution. Eventually, we did. This is how the app startup time graph looked last year. So it had peaked during March. So you can see it is 6 seconds. It's a lot, and we had to take some steps. In this case, the Jetpack benchmark, and the graph gradually decreased, which eventually led to good reviews. Effortless search, convenient scroll through the app. So we had broken the chain. So let's get to the agenda. I'll be talking about benchmarking, Jetpack benchmark, and what's the benefits and importance of it, the setup, what is benchmark state, what we did at Zomato, and what's new for the library in the later versions. So, benchmarking, what is it? It is the practice of measuring the code performance. Basically, we want to know how much time it takes to run some chunk of code, and we want to measure it in a way where we can see our improvements reflected in those measurements. So in short, benchmark is to evaluate or check something by comparison with a standard. You're comparing something with a standard. This is the benchmarking in the cycle of performance optimization. Basically, you inspect, you improve, you monitor. You inspect, you improve, you monitor. And it is the process of testing the performance of program code. Changes must be measured because measurement will tell you how your build has improved or degraded your app's performance. So you can measure it release by release. Benchmarking, why and when do we need it? We need it to determine whether the result of optimization is worth the cost of maintainability. Benchmarking helps you to find expensive operations that are worth optimizing. It can also expose why the operations are slow by showing what is happening while they run. Performance must be measured. You cannot base your roadmap on a guess or a hunch. You need to look at numbers. So here comes Jetpack benchmark. It is a Jetpack library that measures the performance of Android app code. It helps reduce measurement errors that are easy to do in general and is integrated into the Android Studio. it is a library for benchmarking and it is designed for performance testing. Let's look into some of the benefits. Improved app performance. Benchmarking helps identify and address performance bottlenecks, which also helped us. Identifying bottlenecks provides insights into CPU, memory, and other resources usage. It prevents regressions. Benchmarking prevents performance regressions in new app versions because you get data about your performance. And it helps to ensure consistency. It helps maintain consistent performance across devices and configurations. So what are the approaches for benchmark? There are two, macro benchmark and micro benchmark. Macro benchmark library is designed for benchmarking application launch, user interactions, interface manipulations, list scrolling, animations. Basically, the library performs testing in a separate process from the application, and one iteration of the testing cycle takes quite time and may exceed a minute. Macro benchmark needs minimum API level 23 to be implemented. Next, we come to micro benchmark. It is a library intended for benchmarking frequently called functions. For example, measure or layout pass in views, layout inflating, data parsing, CPU calculations, and other code fragments or processes which are executed repeatedly. Testing is done while the application is running, and iterations take no more than 10 seconds. So it's a quick one. And the minimum API level required for implementing micro benchmark is API level 14. Let's look into the setup. You need to create a new benchmark module. It's available on Android Studio greater than 3.6 version. We implemented directly on our main module because the module structure of our app back then, when we had implemented benchmark, was of an ideal real project, and the dependencies were not that simple. Hence, we had to implement it on our main module. So let's come to the real world app setup. You need to add these lines in your Gradle file. One is the class path, then the implementation. You need to apply the plugins. Then you need to declare the test instrumentation runner and the test instrumentation runner arguments. Basically, you need to suppress some errors so that the benchmark does not throw an error while the test is being run. So configuration errors like debuggable is set to false. It needs a physical device, not an emulator. The device should have sufficient battery level, and clocks are logged if the devices are rooted. So we need to suppress these errors during the setup. Additional setup, to get the JSON output, we need to enable the last line, basically enable additional test output as true, so that you can get a report out of the benchmark. There's an also additional step when using AGP 3.5 or lower and targeting API 29 or higher. You need to add a flag to your Android manifest in the Android directory of your benchmark to enable legacy external storage. So you need to add this line, and you must opt out of the scope storage by setting it within the benchmark module. That's all for the initial setup. Let's look at a sample benchmark file. This is how a sample benchmark file looks. Here you can see we have declared a benchmark rule. Benchmark rule is just a JUnit rule for benchmarking code on Android devices. And then we have the test function, which has, as you can see, a measure repeated function. Measure repeated is an inline function where you put up what you want to run and it continuously runs the job. Whatever you put it there, it will run that code continuously. Here you also need to clean the slate before the same operation starts again, so that you can start it from a clean slate. So we can use a function run with timing disabled, where you want to exclude time measurements, so that those time is not included in the measure repeated and does not alter your result. Let's look at benchmark states. There are three types of states mainly: warm up, running, and finished. We can get the state by using the benchmark rule. There's a function called getState function, which returns the state of benchmark. In the warm up state, the code under benchmark will be run multiple times. And when slow exponential moving average approaches the fast exponential moving average, the warm up state will transfer to the running state. I'll show you how it's done. Basically, there's a file in the Android archive in the benchmark directory, warm up manager. There's a function on next iteration. It returns true only if the warm up has been completed and returns false until the warm up has been completed. So that's when you get into the running state. In running, there will be several measurement repeats. Inside every repeat, there will be several iterations. Only the average of iterations will be recorded. So the results will be average of repeat 1, average of repeat 2, average of repeat 3, and so on. The running state has a function keep running. It returns false to quit the loop, and thus we enter the finished state. In the finished state, the statistics of all the measurement repeats will be sent to Android Studio console and appended to the JSON file output. These are the benchmark states. Now we are ready to jump in. This is what happened after we implemented benchmark, the one I showed before. So what we did at Zomato. Let's see. This is the file for the benchmark test. Let's break this down. Here we declare all the variables needed, and we don't initialize it yet. We just declare them: the recycler view, the universal adapter, the test activity test tool. So activity test tool has been deprecated recently. We can use activity scenario for that, and we do only the initial setup here. We just declare everything, and in the next step, you can see add thread before annotation and setup. Here we initialize all the variables, and the basic setup is complete. We initialize the adapter, view model, and stuff. And after this step, we are ready to jump to the actual test. These were just the setup. This is the final test function which we write. Here you can see the measure repeated function. It takes care of making repeated calls to smooth scroll in an environment to benchmark, dependent on the benchmark state. The measure repeated is dependent on the benchmark state. And here what we are doing is we are scrolling it to the end of the recycler view. So this was the test. Now let's do what we do the best: automate. So this is the YML file, and it has three major steps: basic setup, running the benchmark tests, and committing and pushing the output file and comparing it with the previous output we had. Let's look at them one by one. So this is the first step, where we declare the environment and use the secrets for running the test on CI. And we run it on the release branch. These are the jobs of the YML file, and let's look at this one by one. In this first step, this action checkouts your repository under your GitHub workspace. So your workflow can now access it using the token. And next is step 2, where we run the benchmark tests. You need to specify the API level, and the script is the benchmark test.sh. This script gets run. Let's look at the script. Here we are printing that we are running this test, and we run the Gradle command Zomato connected production GMS Android test. Ideally, it should be Zomato connected check. The Gradle task should be this, but it runs on all variants and debug and prod builds. We did not want that. Connected check internally uses connected Android tests. So, as a conclusion, both connected Android test and connected check run the same tests. We wanted it only for a specific variant, so we added the GMS Android test. And this is how a sample result looks like for a benchmark test. And the result shown in the Android Studio console, in this case 7084 milliseconds, is the minimum of several repeats. This is just an example of how the report looks like. Let's move to the step 3, my favorite step. This step helps us to update our old data and replace it with the new one. So we have a file compare benchmark results.sh, and we run that script. Let's deep dive here. This is the file, and what we do here is we compare the old results to the new ones and create a PR, pull request, with the new output, and add a comment to it which shows the difference between both the outputs, the previous one and the new one. Let's look at this one by one. First, we take out the old data from the JSON file, benchmark result.json. Benchmarks 0.total runtime ns gives the seconds taken to scroll to the end of the recycler view. Then we get the old data in it. Then we change the path for the additional generated file. It gets generated in the outputs folder. And then we copy everything from there into a local file. And then we pick up the new data in the similar format. And here we have both the old data and new data. Then we find out the difference, and we keep a comment variable and we initialize it with the difference. In this step, we make a new branch and commit the file and then push it to the GitHub. This is the final step. Here we actually create the pull request. Here you can see the PR title has been mentioned, running benchmark test. It uses the source branch, which eventually is the version name of the version in which we're running. And then we have the PR body. We have these two files, get changelog and create PR, which helps us creating the PR. And then we finally run single comment.sh, which comments what has been done. This is how the sample benchmark result JSON file looks like. It's a sample one. And here you can see that total runtime ns is there. It shows the total time taken in nanoseconds to run the job. There's also a key minimum, which shows the minimum time taken to scroll, and maximum shows the maximum time taken to scroll. Since there are multiple repeats, we need to find the average. And that's it. what we get finally is that a PR gets created with the title running benchmark test and the version name. And in it, we get the comment from the bot itself, the CI bot, that congrats, there has been a decrease in total runtime, or maybe sometimes increase in total runtime. Another example of comparison, this is an example of comparing JSON parsers performances. We have Jackson, Kotlin serialization, Moshi, and JSON. On the left, we have the time in nanoseconds, and sample 1 has the least amount of data, and similarly sample 3 has the largest amount of data, and we can clearly see Moshi is the winner. You can find similar experiments online on relative layout, constraint layout, and linear layout, where people compare all these using Jetpack Benchmark. So what's new now? The measure repeated function has evolved, literally, and we can call measure repeated on the macro benchmark rule. And now this function allows you to define different conditions for how the benchmarking should work. We'll look at the parameters in the next slide, one by one. These are the accepted 7 parameters, among which 4 are mandatory. Package name of the target module. Metrics is the list of metrics to be measured. It is the main type of information extracted from benchmark. They are passed to measure repeated one at a time or can be passed in a list. The available metrics are startup timing metric, frame timing metric, and experimental trace section metric and power metric. Then we have iterations where you specify number of measurement iterations. Then we have the measure block in which you specify the action to be measured. Then there are 3 optional ones. Compilation mode, which is the application compilation mode. Namely, what part of the application should be pre-compiled before the measurements are taken, we need to specify. Before each new benchmarking run, the compilation state is reset, so the previous runs do not affect the subsequent ones. The different compilation modes are partial, full, none, and you can even ignore the compilation mode. Next, we have the startup mode, which shows the application startup mode, which I'll cover in the next slide. And then we have the setup block, the action performed before each iteration. So the 3 startup modes are cold, warm, and hot. Cold starts from scratch. The application process has not been started. The activity has not been created yet. It's a fresh start. Then we have warm. The application process is launched, but the activity has not been created yet. Then we have the hot. The process and activity are launched. The activity is moved to the foreground. So hot startup mode is the fastest one where you can measure the benchmark. Benchmarking versus other tests, we have unit testing. Unit testing focuses on functionality, while benchmarking is about performance. We have instrumentation testing. Instrumentation tests check app behavior, while benchmarking measures speed and resources. Yeah, that's all, folks. And these are the references. Some blogs, and obviously Google. And I would also like to thank the library developer himself, Justin Lamb. And a lot of my bugs were resolved by him using Twitter DMs. So thanks a lot. Thank you. That's it.